So in this lab, we're going to explore encryption, and we're going to use the OpenSSL library to do that. So we're going to use OpenSSL to first to encrypt the file with a synchronous algorithm, right? So that means we're going to use the same password to encrypt the file as we do to unencrypt the file. We're going to use AES-256 to do that. We'll also look a little bit at some of the commands that we can use with OpenSSL just to kind of familiarize ourselves with it. And then we're going to do some asynchronous encryption. This is where we are going to use one password to encrypt the file and a different to unencrypt the file. Not really a password, right? We're going to use certificates or key files. We're going to generate keys, and one of them is going to be a public key, the other one a private key. We'll see how to do that, and then we'll see which key we use to encrypt and unencrypt. And then the last part, we are going to look at hashing, right? So hash algorithm. These are one-way encryption algorithms usually used for, validating files and things like that. So the combination of all three is really needed for most things we do with encryption, right? So if we're, for example, going to a web page that's encrypted and we're going to put our credit card number in, really all three of these mechanisms are involved in those transactions, right? If you're building VPNs, for example, right? If you're creating VPNs, you're doing some network security, you're going to see all three of these referenced when you're creating a VPN. They're needed for different things in the process, right? So it's really a combination of all these technologies. We don't generally just use one of these. Now, of course, you could just use, say, for example, synchronous encryption to encrypt the file, send it to somebody, and let them use the command to unencrypt it. And there are other commands to do that as well. In Linux, you can use PGP or GPG, right? Something like that. We're going to use OpenSSL in this lab because it supports all the types of encryption that we need to explore how this works. So first, let's use the OpenSSL version command, right? We're just going to use the keyword version to tell us what version of OpenSSL we're on. In my case, I'm on 1.0.2. It's important to know what version of OpenSSL you're using, or any encryption library, because occasionally there are vulnerabilities that are discovered in these encryption libraries, and you want to make sure that the one that you're using isn't susceptible to one of those vulnerabilities, right? It completely discounts the use of encryption altogether if it could just be broken anyway, right? We're going to see an example of that later on. We're going to see how that works, how people break encryption. Next, I'm going to run a command that is going to list all of the different commands available to us with OpenSSL. I'm using the less, I piped it to less so that we can kind of scroll through this a little bit. So these are all the different commands that you can use. So for example, ENC we're going to use a lot in this lab, right? That's where we're going to encrypt a file, right? It's the command to encrypt something. Rand, for example, can create random numbers. And we'll play with a few of the other ones here as well. When you're done looking at this list, you're going to hit Q to quit. Now, likewise, you can also run a command to show all the cipher commands, all the different algorithms that are supported. Again, I piped it to less so we can scroll through it. So we're going to use AES-256 CBC, but there's a whole bunch of other ones in here. DES, for example, the RC2 and 4 and 5, and so forth and so on. So there's obviously different cipher, different encryption algorithms that we can choose to use. Hit Q when you're done looking at these different algorithms. Now, in order to play with encryption, first I have to have a file to encrypt. If I take a look at the files I have in my home directory, I'm going to make a new file or a directory, and I'm going to call it, I'm going to call it encryption. Right, so there's my encryption directory, and then I'm going to change into that directory. So I'm going to kind of use this directory to create all the files that we're going to use to play with here. Just to keep my screen from getting too cluttered, I'll clear the screen. So now I'm going to use VI to create a basic text file, right? I'm going to call it myfile.txt. So for my text file, I'm just going to put a poem in here, just a very basic text file. And then I'm going to save it by hitting escape and then WQ exclamation point to exit. And now that I've done that, I can look at the contents of that file, right? So there's my contents. Next, I'm not going to encrypt the file. I'm going to convert it to base 64. So it's going to convert, basically it's going to take my file, the binary contents of the file, the ones and the zeros, and it's going to take each group of 8 ones and zeros, or each octet in the file. It's going to basically convert that to an ASCII character, more or less an ASCII character, and that's how we're going to work with the file as just plain ASCII text, right? And that's important because a lot of encryption algorithms aren't going to work with things like binary files, image files, and so forth. It's a little bit easier to work with them if they're just binary, right? If they're just they're text only. But then and essentially using something like base64, you can convert any file into just a text file. Doesn't matter if it's an image, if it's a video, if it's a movie, if it's what have you, right? They're still big files, but we can convert them into something that's just plain text, and it's a lot easier to work with encryption. So let's take a look at how to do that. So it's pretty basic. I'm going to use the OpenSSL command. The key, encryption is the command. Base64 is the algorithm. It's not really an encryption algorithm, right? It's still plain text, right? Because anybody who has a base64 encoded file could just, unencode it, and they have the original file again, right? They don't need a password. They don't need a key or anything like that. Most of these commands you'll see have an in and an out. In is the input file and out is the output file. And when I hit enter and type ls, you can see I now have a myfile.bin. And if I look at the contents of myfile.bin using the cat command, and we can see there is the encoded version of the file, right? The base64 encoded version of the file. Pretty straightforward. I'm going to clear my screen to keep that clutter out of our way. So next I'm going to actually encrypt the file. We're going to use AES256. So you can see here I have, again, the encryption command, ENC. The algorithm is AES256, which is a synchronous encryption algorithm. In file is my binary file, not the text file, right? The binary file. And in the out file, I'm calling myfile.cipher. Now, when I hit enter, it asks me to provide a password for that file. I'm just going to make it password, just to keep it simple, right? It's a terrible password, but just to keep this simple. So now my file should be encrypted. And if I take a look here, I now have 3 files. I have my original text file. I've got the myfile.bin, which was the AES 256, I'm sorry, the base64 encoded file. And then myfile.cipher is the AES 256 encrypted version of the file. I can take a look at it if I want, right? It's just going to be a bunch of junk in there. I won't be able to see anything, right? But that's what an encrypted file looks like. It's just a whole bunch of junk. Let me just clear the screen to keep all the clutter out of our way. So I'm essentially going to run the same command I ran before, but this time I use -d, which indicates that we want to decrypt the file. But I still have to provide the algorithm and so forth. So in my example here, I'm going to call the out file myfile.d_bin. So I don't mix it up with the other version, right? The one that before we encrypted it. So this is going to be my decrypted bin file, which we're then going to turn back into a text file again, right? When I hit enter, it's going to ask me to put the password in that I created for that file. And that's it. So now I should have my decrypted version of that binary file. Let's take a look at that and see what it looks like with the cat command. There it is. It looks very similar. Should be exactly the same as the version that we encrypted. So now I'm going to unencode the file back to regular ASCII text, right? It's not going to be base64 encoded anymore. That's what the -d does, right? It's decrypting, even though, again, it's not actually encryption when we're using base64, but the syntax is the same. And I'm going to call my output file myfile.d_text again, so I don't mix it up with the file that we encrypted. When I run that command, let's take a look. Where is my decrypted file? It's right there, myfile.d_text. I'm going to use the cat command to take a look at that, and assuming we did this right, we should have the file that we originally created. And there it is, the poem that we had originally. So that's an example of synchronous encryption. We use the same password to both encrypt the file and unencrypt the file. So now we're going to use some OpenSSL commands to do asynchronous encryption, which means we have to first generate a private and a public key before we can encrypt it. So we're going to encrypt a file with somebody's public key, and then we're going to unencrypt it with our, whoever we send that file to would unencrypt it with their private key. So let's take a look at how that works. So the first step is we have to generate our keys. So we're going to use the gen RSA command to generate some RSA keys. The out file is where we're going to put that key, right? It's going to be key.pem, and 1024 is the bit depth. So let's go ahead and try that. All right, that has created our key files, right? If you run the ls command, you can see I've got my key.pem file right there. So from that key file that we generated, we have to extract 2 keys from that. One, it contains both our public key and our private key. So first we're going to get the public key. I'm sorry, we're going to get the private key. We can tell it's private because when we extract it here, we are going to encrypt it with triple DES, right? With DES3. We could have used AES if we wanted to, right? But we want to encrypt that with a synchronous algorithm. That means that it's the same password to unencrypt and encrypt it. Now, why are we encrypting that private key? Because if anybody gets their hands on that private key, they would be able to decrypt any traffic that was intended for us, right? So we want to protect that private key. So let me go ahead and do that. I'm going to put a password in for it. Make it really simple. I made a password. So now I'm going to output the public key. It's the exact same command, only this time we're not going to encrypt it, because why would we encrypt our public key? We want to be able to distribute it to anyone, right? Anybody could take our public key and use it to encrypt something to send it to us, right? So I'm going to use the -pub out option, which is telling the RSA library that we are trying to get the public key from that key file. So let me run this, and that should output the keys. If I type the ls command, you'll see that I have pub-key.pem, which is going to be my public key. That's the one that I would give to someone else who's going to encrypt something for me. And in order to decrypt that file that somebody gives me, I have to use enc.key.pem, right? Key.pem, if you remember, is the whole key file. Now, at this point, we could theoretically delete key.pem, right? We don't need it anymore because we have our private key, we have our public key, and probably would be a good idea to delete it, right? The public key we could distribute to whoever we want. The private key, which is encrypted, we would keep it encrypted. That way, nobody could steal it and use it, right? If we keep the key.pem laying around, it's something that somebody could, steal and they could use it because it's not encrypted, right? Or we can encrypt that file as well, right? We can encrypt it. We just learned how to do that previously. Now, next I have to make a file that we're going to encrypt, right? I'm going to keep it really simple. I'm going to call it RSA. Actually, I'm going to call it passphrase, right? Because a lot of times when we're doing asynchronous encryption, we're encrypting a passphrase that we're exchanging first before we do one of the other algorithms, right? One of the synchronous algorithms is much more, they're much more efficient, right? So I'm going to make my passphrase. This is my making it really short, right? You generally want to keep, you can't use huge files with these algorithms generally. All right, so now if I take a look, I have my passphrase file. That's the file I'm going to encrypt with my public key, right? So now we're going to kind of switch roles. Let's pretend that we're someone else, and somebody has given me this public key, right? Now I'm going to encrypt the file with somebody's public key. So now it's encrypted. Nobody else will be able to unencrypt that file except for whoever has the private key that goes with that public key. So let's see the command to do that. So you can see here I'm using the RSA util command. We're going to encrypt a file, right? We're telling you we want to encrypt it. I'm going to pass in my passphrase file. That's the input file. So that should have worked. We're going to use the ls command, and there it is, passphrase.enc. And just to show you, it should be encrypted. And there's really nothing there, right? So it appears to have been encrypted. Because if I count the contents of passphrase, right, there's my passphrase. Okay, let me clear the screen, keep the clutter out of the way. So now we're going to switch roles a little bit, right? So we've encrypted the file using somebody's public key. Now I'm going to pretend that I'm a user that received this file. Somebody encrypted it with my public key, and now it's time to unencrypt it with my private key, right? Which is the enc-key.pem, right? The encrypted private key.pem. So this time, instead of -encrypt, now it's going to be -decrypt because we're decrypting the file. So I'm going to pass in the path to my private key. Then I'm going to pass in as the input file the path to my file, my encrypted file that I had received that I'm trying to unencrypt. And then finally, I'm going to output the path. I'm going to give it a path to output the file. I'm calling mine passphrase.pt, short for plain text, right? And when I hit enter, it should work, but it's going to ask me for the triple DES password, right, that I created earlier for my private key. I typed in the password, and now if I type the ls command, I should see my file. Where is it here? There it is, passphrase.pt. So I'm going to output the contents of that file. This is my passphrase. So it worked, right? So we're able to encrypt the file with a public key. Well, first we created our keys. Then we made sure we encrypted our private key, right? We were able to use the public key to encrypt the file, and then the private key to unencrypt the file. And remember, a public key we could distribute to anyone we want. The only thing you can do with the public key is encrypt the file. You still need the private key to unencrypt the file, which we encrypted with a synchronous algorithm so that somebody, if they happen to steal that key, they wouldn't be able to use it. So now we're going to take a look at hash algorithms. Hash algorithms are not really encryption in the sense that we're encrypting a file to protect it so that we can then get the file back, right? And be assured that no one has seen the data in transit or what have you. Instead, with hashing, we're making a fingerprint of a file so we can identify if a file has been changed, right? Validating that it's the same file that we thought it was before, right? So again, you can think of it as kind of a fingerprint. I'll show you an example of this. So in my directories, I created two files, file 1, file 2. You'll see them in my list here. They're on the left-hand side there. So if I use the cat command, I can output the contents of both files, right? So I'm going to output them both one on top of the other. You can see that they are exactly the same contents. Now, if I use the OpenSSL command, and I'm going to use the digest command, right? So digest is how we do hashing, right? I'm just going to use MD5. There's various hash algorithms you could use. I'm going to use MD5. I'm going to do it on both file 1 and file 2. I'll do it at the same time so I can see them stacked right next to each other. And you can see that they are the exact same fingerprint. I could do the same thing with SHA, right? So maybe we'll do SHA 256, right? It's the exact same fingerprint because they're the exact same files, right? Now let's say I make one minor change to one of the files. So let me open up file 2 with VI, and all I'm going to do, I'm going to go to the end of the file and I'm going to add a dot at the end. Proper grammar, right? That's it. One minor change to this file, and let's see what it does to the hash algorithms. So the 256, you can see it's completely different now. Same thing with the MD5, right? So let's take a look at MD5. And you can see that they are completely different now, right? So it worked. It told me that somebody adulterated that file. It's a completely different fingerprint. Now, often you'll hear people talk about how MD5 is broken, right? So lots of different hash algorithms. We just looked at two, MD5 and SHA 256. So some people will say that MD5 is broken. Well, you just saw me use it. It worked. How could it be broken, right? The idea is that it's possible to have two files that are different that will have the same digest, right? They'll have the same output from the hash algorithm. I'll show you an example of this. I don't recall exactly where I found these images. It was years ago when I was, teaching one of these classes, and I found an example of two images, right? These are both just JPEGs, right? They're just pictures. And somebody messed around with these files so that it will trick MD5 into both of them having the same hash, the same digest, right? So let's see if we can actually get the digest in these two files and see what that looks like. So I'm going to copy these up to my server. So in order to copy those files, I'm going to use the SCP command. There's a variety of ways you could do this. You could also use SFTP. You can download an SFTP client. But if you're using Windows PowerShell, or if you're on a Mac and you can get to the command prompt, just the same place you would run the SSH command, generally you also have the SCP command. Secure copy, basically, right? I think we've used this before. So the first argument is going to be the source of the files. In my case, mine were in a folder called files, and there's only two of them in there. And then the destination for me is going to be my student user at my IP address, :tilde means in my home directory, / encryption to put it in that encryption folder. So I'm going to go ahead and run that. It's going to ask me for my password. And you'll see it copy my two files. So they should now be on my server. So come back over to my server. Run the ls command. There's plain and ship, right? And if I do a digest on those two files, so we'll do plain.jpg and ship.jpg. And let's take a look. It looks like both of those files, I know one's a little offset, right? But look at the actual numbers. It's because one of the file names is a little bit shorter, right? But if you look at the actual digest, they're exactly the same. And I showed you, right? These are different files. They're completely different photographs here, right? You can see them right there. They're not the same picture. There's no way that they should have the same digest. They're completely different. Now, one thing that we should be a little suspicious of, right, is if you look at these files, right, I'm going to use ls-al, look at the size of the files. They're exactly the same size. And what that tells me is that somebody probably messed around with these files and did something to get them to have the same MD5 hash. So it's not like somebody took two random pictures and then they just magically had the same MD5 hash. It would be incredibly unlikely, number one, for that to ever happen, and number two, for anybody ever discovered two files that would do that. So this is clearly somebody went out of their way to make these files so that they would have the same hash. And just to show you, SHA-256, right, as an example, if we use that digest, now we get different digests, right? So SHA works. It's not tricked, right? It sees these as two different files. So just an example for you.